Hello everyone, I am Samatma Bharadwaj and this is my presentation for task 3 for the organization Liquid Galaxy for GSoC 2026. So today I'll be explaining how version control works, how Git internally manages history, and then contributing to open source projects, for example Liquid Galaxy. So before we start, let me ask a simple question. Have you ever tried creating multiple versions of the same file, like project 1, project 2, project final? Yeah, you usually do that. So this problem is the reason why version control exists. So, in this session, it is structured into four parts. First, we'll see fundamentals of version control, and then Git workflow, and then GitHub collaboration, and then how this applies to open source contribution, like specifically Liquid Galaxy. So, by the end, you are supposed to understand not just the commands but the underlying system design. So, the problem without version control is uh, we face four core problems. There are no traceability, uh, past traceability. There are no safe collaboration. There is no rollback mechanism, and then there's a high risk of overwriting work. So, in professional projects or professional coding, traceability and auditability are extremely important. So, it avoids creating multiple file copies. It like as we told, project final v2, latest, real, like that and all. Everyone names their files like that, and then it makes collaboration easy. It avoids code loss, and then it helps in tracking the change. So now let me ask you a question. If a bug appears in the final production, how do we know which change actually caused that? So you can test the previous versions, and the version which worked, you can make it the production version. So this is the reason why version control exists. So this is a visual showing how versions are stored in the database. So each version is stored as a snapshot. So Git does not store it does not store changes like line 4 is added, line 4 is modified. It stores the entire snapshot. So uh, so these are stored as version 3, version 2, version 1. So if version 3 there's an error, you can come back to version 2, like that. So Git stores the entire snapshots. So there are three types of version control system, which are local VCS, centralized VCS, and distributed VCS, which is Git. So now let us see the visual here. This is basically a rough visual representing each of that. So local VCS is where history is stored only locally. So this is basically keeping in focus a single user. So centralized VCS means a server stores the history. So if there's a server failure, then it's a history loss. And then distributed VCS is basically every developer has full history. So this eliminates the point of failure and allows like offline commits. So the Git is distributed, and this is the biggest advantage of Git. So what is now? Let us go through what is Git. So Git is a distributed version control system designed for speed, integrity, and non-linear development. So we'll see each of these later. So it was created by Linus Torvalds. It tracks project snapshots, and it is optimized for large-scale collaboration. So internal model is Git uses a directed acyclic graph to represent commits. An acyclic graph is a graph which is not a cycle. So the head and the tail don't meet each other, and so the commits are represented that way. So that way each commit references to its parent commit. So now let us go through what is Git versus GitHub. So Git is a local CLI tool, command line interface tool, whereas GitHub is a cloud platform, is a web cloud platform. So Git is used to track changes. Basically, Git is used to track changes, whereas uh, GitHub is used for hosting projects, remote collaboration, and all. And then this is CLI based, and GitHub is a web platform having collaboration UI. So can Git function without GitHub? Yes, but GitHub cannot function without Git. So now let us see what is a repository. A repository is a directory tracked by Git containing code, commit history, branches, documentation. So the actual metadata lives inside the .git directory. We'll see the .git directory later. So each repository contains working data, staging area, object database, branch reference. So we'll see all of these later. So the standard workflow is the life cycle of Git is you first clone a repository and then branch a particular part of it and then edit and then commit your changes, push it back, and then the pull request. So in the next slide, we are going to see exactly how this all works. So this basically separates development from production code. So you direct changes to the main branch, and in larger teams, direct changes to the main branch are restricted. So this is the Git architecture. This basically is the entire underlying working of Git. So if we learn this, we basically know the entire working of Git. So a remote repository. So this is a remote repository, which is the central collaboration point. And then a local repository. This stores committed snapshots on cloning the remote repository. A local repository which stores the committed snapshots. A staging area is an area where changes are prepared. It's an intermediate area on which, and the working directory is basically where you make the files or edit the files. So uh, we basically clone a remote repository into a local repository where it stores the committed snapshots, and then we make the changes in the working directory and then add the file to the staging area, and then from the staging area it is committed to the local repository, and then it is pushed to the main remote repository. So the main flow is working and then adding to the staging area and then committing to the local repo and then pushing it to the remote repo. So now you may have a question: why does Git use staging area? So it allows it is used to prepare. It is an intermediate area to prepare for the commits to the local repository. So this is basically the same thing explained in a more or understandable or an organized way. So you on from the working directory, you add it to the staging area. From the staging area you commit to the local repo. From the local repo you push it to the remote repo, and then you can do whatever you want from there. So cloning a repository is Git clones to create a full copy of the remote repository, including its complete history. So it also sets up remote tracking. So it also sets up remote tracking. This, you may think, why do we need that? We can directly download the file. But then basically when you download the file, you won't have the remote connection, remote tracking, or the snapshots history and all won't be saved. So you won't have version control of it. So you use git clone of a particular repository. And then now let us see what is git branching. Branching is basically a movable pointer to a commit. So when we create a branch, Git does not duplicate files. It just think of it like a pointer. It just creates a new pointer. So it is used for safe experimentation, feature development, and parallel work. So the branching strategy diagram in which branches are divided in the following ways. Master is for production, develop is hotfix is for emergency fixes, release is for pre-production, and then develop is for integration, and then feature is for new developing extremely new features. So this structured branching matters because it provides a proper stability, and each features are isolated from others by this. So in this slide, let us get started with Git. So let me demo that in my terminal. So I have Git installed. So let us check that using Git version. So on doing Git version, you get the Git version which I have on my PC is version 2.43. So now let us create a project folder mkdir demo. Oh, the file already demo one. So we created a directory called demo one and then cd demo one. Let us go into that directory. So right now this is a normal directory. Git is not tracking here yet. So now let me initialize git init. So it initialize an empty repository. Now the let us do see the stored files here. So yeah, .git directory is seen. So this stores the commit history, branches, configuration, objects, etc. So now let me create a first file with the following content. Hello world. And then let me write that to a file called file.txt. Yeah, and now let me check it status. So now we'll see it under the untracked files column. So this means Git can see the file, but it can't manage it yet. So the changes to it right now are not stored in the .git directory. So now let me add that to the staging area, which is git add file dot, and now let us see again git status. So yeah, now it tracks each changes you commit to it. So this was the staging area is the preparation area before creating snapshot. So now we added our file.txt to the staging area. So now let me commit a snapshot. Git commit um this again. I write an empty message, or I write hello. Added my first commit. Oh, sorry, a typo. So yeah, the commit was successfully done. So now let us check history of git log. So yeah, it is done to my GitHub repository. So now it is done in my account. So now let us connect it to a GitHub repository. So I have the remote repository which we saw there. So I have created a sample empty repository called demo. Let us add it there. Git remote and origin. So yeah, now let us verify connection using git remote slash v. So now we see this origin is basically the name of the remote repository. So now let us push the changes to GitHub. So we first ensure the branch is main git branch slash m main. Now let us push it to GitHub. Git push u origin main. So you here. So now let me put my username and password. It asks for it. Oh, the password was. Let me try that again. So now hopefully. Does push add changes to Git? Slash u sets the upstream tracking. So on setting username, I created a token. So yeah, it says branch main set up to track, and then everything up to date. So I to my pushed it to my repository which I connected here, and then we checked it. It showed everything is up to date. So now let us make another change and check the update flow. So let us add one more line. Second line added, and then write that to file.txt. Yeah. Now let us check git status. So now our branch is up to date with. So it shows this is modified. Now let us add git add slash dot, and then now let us check its status again. So yeah, now let us commit this update. Git commit slash m added second line. Now let us do git push. So now let us check in my repository. Uh, this repository has file.txt. It was empty before, and then yeah, it has the two lines which we committed, and we also get the commit history. So uh, let us go back to the files, to the slides, and then simply revisit. So mkdir is command for creating the directory, cd is for going to the directory, and then git init is for initializing the git, and then hello git, you write that to the file.txt, and then git status is to check the status, and then it compares the working directory with the original one, and then git add updates the staging area. So nothing is actually committed until we git commit. So when we do git commit, the commit contains the tree object reference, parent, commit hash, author, metadata, and then timestamp, and then the commit message. So uh, git remote add origin is used to link the local repository to the remote repository, and then git remote is used to check the connection, and then git push transfers local commits to remote repository. So until then push commits only exist locally. So local repo meaning on your computer, and then remote repo. So before push it exists locally, and then after git push it exists in both the places. So the workflow is fork, clone, branch, commit, push, pull request, review, and then merge. So in most open source organizations, it's like that. So the conclusion is version control is not just about saving files, it's about managing the history, and then ensuring collaboration, maintain and then integrity, and then enabling a scalable development. So every open source project in the world, including Liquid Galaxy, relies on this exact model. So Thank you for attending this. Hope it was useful.